Hi everyone. My name is Raphael, right? So first of all, don't get fooled by the fancy title, CTO, right? Because being a CTO on a small startup means just like you're a developer with more work to do, right? So it's a very, very underpaid position. I'm from Brazil, so one thing that you should know about me is that I am a very, very passionate Elixir lover, right? So I had some experience with Ruby before, and I really enjoyed all the features, all the tooling, but yeah, I never really felt like it was the best tool to build like a huge, a big software, right? And I know some people do. So yeah, it's just my personal feelings. And I was reading the 7 Languages in 7 Weeks book by Pragmatic Programmers, and I found about Erlang there, right? So then I immediately fell in love with Erlang model of process and actors, right? So the concurrency and the safety part really spoke to me. So the first time I wrote a process and killed it, and it got restarted. So it was like, whoa, this is awesome, right? So, but at the same time, the syntax and the tooling didn't spoke to me like Ruby did. So I was like, okay, I really like Ruby. It's fun to write code, but I really enjoy Erlang the Erlang philosophy, the Erlang ways to do things. And so I went to Google and I searched for Erlang plus Ruby. Yeah, that's actually the search query I ran on Google. And I think the first or second result was Elixir homepage, and it was like 3 years ago, so 3-4 years ago. So it's funny because I was reading an interview with José Valim, and he said his story was almost like mine, right? So he liked Ruby, but he was looking for something different, and he found Erlang. But apparently when he ran this query, he didn't find much, right? So yeah, that's how we got here. Well, I work at this company, Eficiência Fiscal. This translates roughly to fiscal efficiency in English. And what we do is make companies' lives easier in Brazil, because we have a very, very crazy tax policy back in Brazil. It's nuts, right? Actually, it's so crazy that a recent PwC research, actually not that recent, pointed out that Brazilian accountants spend 2,600 hours per year per company doing taxes. So it's crazy. For a matter of comparison, in the UK, the number goes to 100 hours, 200 and something hours in Poland, right? So, yay, Brazil. So this opened an opportunity for us to create this company, and we tried to pinpoint how much tax you should pay and what kind of taxes you should pay for each product you're selling. And it's a really good idea back in Brazil, right? So we even got featured on the 100 startups to watch in Brazil. Because of this, our business model, it's really appealing to people back there. So, first of all, this is not a web scale case, right? We don't have millions of concurrent users. This is not our problem. that we try to solve with Elixir, right? So we have like 1,300 companies using our services and 900 active users, so it's not a big number, right? We usually see like, oh, it's a billion users using a software, so no, that's not our case. But we have a high customer to data ratio, right? So this small number of users generated 80 gigabytes of database storage and more than 15 million items that were already processed. So it's a small number of customers and a huge number of data generated, right? So that's the problem. We have a few paying customers and this load of stuff to do, right? So we must do as efficiently as we can, because we can't just like scale and add more servers forever, right? So the problem, we had this huge monolith. Actually, for our perspective, it's a huge monolith because it was a small team. So and Eficiência Fiscal was built on top of this multi-tenant monolith. So we had this application, and when the idea for Eficiência Fiscal started, okay, let's reuse this. So yeah, don't do that, right? It's crazy. And we had code rot spreading really fast. New things that we just wrote were getting legacy real quick. It was really hard to maintain this. And we still had paying users, right? So users were paying to use this. So we couldn't just like, okay, let's scrap this and start over. No, that wasn't an option. And the product wasn't really done yet too, right? So we couldn't just, okay, let's stop creating new features and let's just port everything to Elixir. No, that wasn't an option either. And to make things worse, we had a small team, sometimes just me. So yeah, now that's a thinker. So, yeah, that was the issue. And something I should have mentioned on the beginning of the talk is that I'm not even talking about which stack we were using, because I don't want this to become a whole, oh, language is better than this one kind of comparison. So, but okay, but we didn't use Elixir, that's for sure, right? So, then we had this problem to solve, the watcher. What was the watcher? It should make a request to an endpoint, parse some XML, check if the data changed, and send an email with the changes and repeat again in 1 hour. So we have this problem to solve, and yeah, we didn't feel like our current stack would solve this well. It was really brittle, right? So if you can imagine me on the back of the room, of the development room, raising my hand, hey, I may know something to solve this, right? So I presented Elixir to the team, and people liked the idea, and yeah, then we chose Elixir to solve this problem. Some of you may be thinking, seeing these requirements, that okay, you have used a cron job and some monitoring, right? Yeah. So the results: we had 13 commits, and 4 days later to deploy this first application. It was deployed on 2015, August, and a single commits a year later to do some refactoring, and it's still up and running today, right? So it's still running, and people were really happy with this win, and this win will prove itself really helpful in our future problems, right, that we have to go through. So then, after this, we had this other requirement that we had to, receive 2 text files on an endpoint, parse them and cross-reference them, build this data set, and put them through a lengthy audit process, right? This process is meant to find the correct text for the products of the user. So far, so good, right? Our current stack would be able to handle this, but we had to make sure the thing runs until the end. So yeah, that was a problem, right? So that's when Elixir came in. People were like, oh, we had this kind of problem before when we need to make sure that something ran, right? So yeah, let's use Elixir again. And for our luck, Phoenix 1.0 had just been launched, right? If you see the dates back there, I don't know if everyone will be able to. 28th of August, right? So it was like 10 days after this article was posted, so that we decided to create this with Phoenix. And yeah, we built it, and it was a lot faster than anything else we had ever built. We used WebSockets for live updates of the process. This was nice because we could go to the stakeholders and see, oh, see this updating number here? Yeah, this wouldn't be possible before, right? So it was a nice way to sell Elixir to the remainder of the company. And the thing ran until the end, right? So that was the biggest win. So, and an indirect result is that the code was really nice to read, really nice to change. So yeah, seeing that and seeing what we've achieved using Elixir, we decided to begin the migration. And this migration had all these requirements that I told before. We couldn't just stop developing new features. We couldn't just scrap everything and start over. No, we had to keep both applications running and migrating things bit by bit. So we had like this structure. We have an Nginx server pointing all the requests to the legacy application. Then we added a new rule. Everything with /p would go to the Phoenix application. If anyone is seeing this and going like, oh, okay, that's the way I can do to rewrite an application bit by bit, yeah, don't do that, right? Don't take notes right now. I'll show a better way down the road. So, yeah, we came up with this, and as, I don't know, I think most inexperienced functional programmers went through this, where you can, it's hard to think about how to solve something functionally. So you try to port everything you know from the other language, right? So yeah, that's one thing that we tried to do. We tried to rewrite things, actually rewriting, not porting solutions. We were rewriting code. So yeah, you can imagine that it was kind of messy. So we had two problems with this, with our approach. The first one, the legacy application was too messy for this. Oh, let's just move things. Yeah, we should have seen this coming, right? It's not a hard problem to predict, but yeah, we had this. And the second problem, the team was seeing the Phoenix app as a secondary application, right? So because of this /p, this odd thing on the routes that led to the Phoenix application. People were seeing, okay, this is like some secondary application. We should just use it when our main application doesn't, right? And there's a learning curve in functional programming in Elixir and in Phoenix, right? So people wasn't willing to go through this learning curve. So they weren't seeing the value of using Elixir, using Phoenix. So yeah, we had this problem. And then the migration came to an halt, right? We spent, I think, 4 months without any commit on the Phoenix repo, and things kind of just stopped, right? So yeah. Then, okay, let's change things. Let's try to do things differently. First, we decided to use Phoenix as a reverse proxy to the legacy application. Gladly, this library, Terraform, was just released, right? And by reading this, there was this article, this companion article, right? Rise from the Ashes. It's a really nice read if you are willing to migrate something to Elixir. I really highly recommend you for reading this. So we decided to use this, and at first there was some skepticism about latency. Oh, this will add some unnecessary overhead to our response time. But yeah, whatever, it did anyway. So we had this new structure. Because we had this very heavy front end, very JS heavy front end, most of our logic relied on APIs, right? So we have this /API endpoint that usually went to the legacy application. So what we did is to redirect this on Nginx to the Phoenix app, right? And using Terraform, if there wasn't any routes that could match this endpoint, it will go back to the legacy application, take the response, and give it to the client, right? Just like a reverse proxy. And the overhead was less than 1 millisecond. So it was really, really fast. The usual response times were around 200 milliseconds, so it didn't make any difference on our perception of the application. So yeah, that's one thing that we did differently. The other one was no more just porting the logic. Let's write functional code, you know, and let's solve the problems in a functional way. Let's not just look at our older solutions and port them. That's what I call the Elixir way, right? It's like the path of the alchemist or something. So we did this. We changed our way to creating the solutions in the new application. And one more thing is that we model the application as an umbrella, because as I told before, we have a lot of data, right? So most of our load is not web related. It's background processing. So we have like this background services that have to do their stuff periodically, do some syncing, do some processing. So this switching architecture was kind of funny, because usually we have the two options, right? Monolith and microservices. And monolith wasn't the right one for us, because we had just been out of a monolith. We weren't willing to enter another one. So it got striked out very quickly. And microservices I really considered using microservices for some time, but after seeing some talks and doing some reading, I got the conclusion that microservices are not a way to structure your code, structure your domain, right? It's a way to structure your teams. So if you have a small team like we had, microservices would add some benefits of keeping things separated, but would add an overhead to our development process that we wouldn't be able to cope with. So yeah, that one was out too. So we were looking for this, what's the magical option that will solve all of our problems, right? So we ended up with Elixir umbrellas. They are a very nice and neat way to splitting your code base into multiple applications without all the overhead of having microservices. And yeah, you can do both. You can deploy the applications separately, so you don't have to deploy everything, the whole thing, as a single unit. You can choose what applications in your umbrella you are willing to deploy. So yeah. Okay, so what happened then? The team morals went up. So yeah, people were no longer seeing Phoenix as the secondary application, mostly because they saw how fast it can be. They saw how reliable it can be when you put it on the front of the legacy application. So this had a huge impact on the team's morale. The code became easier to refactor and reason about. So we have a more maintainable code base, and things were moving smoothly, and management was happy because they were seeing the improvements of the new stack. So, yeah, life was good, right? So everything was working, and we have this whole plan on the migration, and everything we're doing, okay, this code is good, this shiny new application, this shiny code. But this happens. Then we are this huge Phoenix application, and go, okay, yeah. Yeah, we're legacy again. So that's life, right? Yeah, but for some time I tried to avoid this change on the Phoenix architecture, and it worked, right? You know there's this thing that you're not doing, and you're like, okay, there's no problem, but it comes back to haunt you sometimes, right? So I had this closure moment when I was explaining our architecture, the way we manage code, right, to a new developer at our team, and he didn't get anything. He was like, oh, I don't understand how this works, right? Where should I put things? Where should I look for things? And for me, it was easy because I got used to that structure. But for a new person, that's when I saw, okay, this is not good. So I gave a try to Phoenix context, and yeah, they are good. They are good. The first context I wrote, I ported some logic to this context, and then I showed him the code and the tests, and he was like, okay, now I get this. So it was really easy. It's really nice to reason about how to structure code. And yeah, so there's I think Chris is doing a keynote on the ending of today, right? So I hope he doesn't get us no surprises, right? Yeah. So okay. So today, We have over 36,000 lines of code in Elixir and growing. Actually, I had to update this slide 3 times because we had first 28, then 30, then 36. It's growing pretty fast, right? We have 3 developers, including me, right, the CDO, and 2 interns, right, training with Elixir. And our umbrella currently has 11 applications. I think four of them are deployable, right? So the other 7 are just dependencies, just libraries, right? And yeah, okay, so I never intended this talk to be like, okay, 10 steps to migrate your app to Elixir, no. So just a story of what happened and what we did that worked and what we did that didn't work. But still, there are some things that we did that might help you, right? If you are anyone here like about to migrate something to Elixir, yeah, okay. So some things that we did that really helped us. One of them, Credo. Yeah, I don't know how to say that. So it's very nice. It's a really good library. The thing about, I don't know, who uses Credo here? Okay, cool. The thing about it is that it ensures a consistent code base. It helps finding simple problems and avoid discussions regarding style. Right? It's like the code formatter. You shouldn't be discussing about 2 spaces, 4 spaces, tabs. Right? No, we should discuss about business problems, solving real problems, right? And the formatter is doing a really good job right now, but there are some things that it's outside of the grasp of the formatter, and Credo covers it. About function complexity and having documentation, and yeah, it's a really nice library, and it avoids discussions like, oh, that commit you made, you should add documentation to that module. No, Credo does this, right? So I really encourage anyone who's writing Elixir to use Credo, and most of all, start with Credo, right? Because one thing is when you start your project using Credo from the beginning, and another thing is when you have like this huge pile of code and you run Credo on it and it finds like 200 warnings, right? So using from the beginning is always the best. Property testing, right? This is awesome. This is awesome. Andrew is giving a talk on this later, so I'm not going to dwell too much on it. And yeah, but it helps catching bugs on edge cases, and it helps testing complex features more easily, right? So you have this complex function that has many conditionals, so you write this bunch of tests to cover all the paths, right, of the function. Using property testing, you can just encode these variances, these conditionals, on your property, right? And you end up with one test that tests the whole thing. So it's really easy to get a good coverage of your code base, a full coverage actually, with a small effort writing tests, right? So yeah, that's it'll be included in the new Elixir, Jose said, but you can use it today with the string data library. So, moving on. And another thing that might help is using Elixir unique capabilities to solve problems, right? So when you get to a problem, you have to find a solution. Sometimes it's easier to go to what you already know, right? So on my previous stack, I would solve this like this, right? I use this solution, this tooling, and Elixir opens up for a whole bunch of different ways to solving things, and most of the time, these new exciting ways makes the solutions elegant and more resilient or reliable than it would be, right? So, and using this Elixir unique capabilities to solving these problems also helps showing management, showing the team that, okay, you see this works because of Elixir, right? So, yeah, and it's not that hard to do that. Actually, hearing what I just said, I want you to be careful to not over-engineer things, right? It's not the same thing. Yeah. An example. We had this very, very simple code, okay? We had this background processing job that should do something with all the companies in our code base. And this thing means accessing an external endpoint, an unknown endpoint, and a very, very unreliable endpoint. So we couldn't just create very parallel workers to do things at maximum concurrency. No, this would like DDoS their service, right? So, yeah. But we needed to do this. Very simple. So, what did we do? This function had only it doesn't actually call do thing, right? It's just a code example, right? So, but the actual function that goes here, it just has the happy path, right? Everything works. And we had monitoring. We use AppSino right now. And okay, so you had the happy path, you have monitoring, ship it. Okay, so yeah, because when you're communicating to an external endpoint, you have all these multiple failure modes, right? Things can blow up in the most unexpected ways. So we couldn't account for all of them, but we needed to do this. So, okay, we shipped the code, it ran sometimes, but we had a problem, right? Yeah, that's a common story in software development. What was the problem? When an error happens to the second company, all the other 1,000 or so didn't do anything, right? So, yeah, we had this problem where errors were happening early on the list of companies and things were just halting. So, okay, how do we solve this? One way we thought about was to add some try-catch here on this function, and in case of errors, manually sending them to AppSino so we can see later what worked, what didn't, right? Because we didn't care if some companies fail, we just cared that everything was processed, and we got to know of any surprises, right? So my first instinct was to do this. Let's put a try-catch and yeah, and send the errors to AppSino. So, but then I started reading about reading the task module documentation and the task supervisor documentation, and I got to this solution, right? So you have a task supervisor. You don't have to actually start it on the spot, right? You can have this task supervisor on the supervision tree of your application. So we have the supervisor, and we just call task supervisor async string no link, this very small function. And what it does basically is creates a string of tasks, right? That where you could run this function for every company in a separate task that wasn't linked to our process. Right? So yeah, what happened? Things still failed. We had some companies that couldn't fetch their data, but they were isolated now. So it doesn't matter. And as every process that dies on the bin, we got to know later through monitoring. Yeah. So yeah, if you include the task supervisor start link line, we went from 1 to 3 lines to solve the problem, right? So yeah, and this is working flawlessly. It's this kind of stuff, this kind of problem that you wouldn't be able to solve like this, or would take a lot more time to do in your older stack. So yeah, this to the management and mostly to the team that's working on the application, this is gold, right? Because they see the power on the new platform. So some closing thoughts. Most of our problems we had were like a year, 2 years ago, something like that. And the Elixir landscape was very, very different back then. We have much more, a lot of tutorials, a lot of articles, a lot of material and examples to base on, right? So I expect people who embark on this journey of migrating things, this huge application to Elixir, to don't go on too much trouble as we did, right? And one thing that I can't stress enough is this book. I wish we had this book. So I started reading it. I read the first 2 parts of it, and this book pointed out so many errors that we did back then and had to suffer the consequences, right? So it's an awesome book. If you're willing to migrate to Elixir, I cannot recommend this book enough. So yeah, I think that's it. Thank you.
Thank you, Raphael. So we have time for about 3 questions.
So hi, I'd like to ask, is the migration over, first? And second, during the migration, how did you handle authentication between the 2 legacy services, or things like database, schemas, migration, and all this kind of, duplicated stuff that you have?
Yeah, actually the 2 applications used a shared database. It's a very classic structure, right? You have the database, the application, and they communicate. And they use the same database right now, but as a rule, to help enforce this Elixir way of doing things, and because Ecto didn't have the schema definition of columns back then too, right? We had this rule where every time we needed some table from the legacy application into the Elixir application, we would migrate data, right? So create new tables. All the tables, the old tables had prefixes. The columns have suffixes. It's crazy odd to work with. So every time we had to port things to the application, we had this rule, right? Okay, let's port the data too. Let's restructure the data. while migrating, and then making some adjustments on the legacy application, so just so things didn't break, right? And we also had a Redis database for some session communication between them.
And what about authentication? How did you migrate passwords from some users to the new system?
Passwords?
Did you have?
Yeah. That's interesting. That's an interesting question. What we did was, first we had to port the old password hashing logic to the Elixir application, right? So yeah, we had to analyze how the hashing worked and port it back. So after we did this, we had 2 columns on the database, like the old hash and the new hash, right? And we are now using, I forgot the name of the application, the library. But we first try using the new hashing method, and then if the column is new or something like that, we fall back to the old method. And every time a users switch passwords, they go to the new hash, right? So we keep both applications happy. And for logins, we are using JWT, right? So we have this shared certificate between both applications, so they both can understand the same token.
How did you deal with problems, or were there any problems round-tripping things like JSON, where the internal representation in Elixir could be different from that of Ruby or Rails?
I'm sorry, I couldn't hear the question.
Is that better? How did you deal with the internal representation of things like JSON data when it's round-tripped? So if you're storing, for example, in the new API data that then goes into the back end and comes out again in the Rails side.
Changing the JSON format, right, for the return of the endpoints.
Yep.
Yeah. Okay. So first, it's not a Rails app, the legacy one, right? But yeah, that's one thing we ran into. We were quite naive before, thinking that we could, let's just replace the endpoints and things will just work. We won't need to touch anything on the front end. Yeah, that's not how it worked. We had to change the front end. So yeah, but since we were solving the problems in a more functional way, no more just porting code, that wasn't that much of an issue, because all the screens on the front side of the application needed some refreshing, right? So we took the chance to improve them.
Right, so let's give our speaker a closing round of applause.